the other thing that happened was a few days ago, there was the 2024 report from AARO with the new director. And the message was quite different, I should say, because they talked about out of those objects that are not drones, about a substantial fraction of them not being identified, and some of them maneuvering in ways that cannot be understood by conventional engineering, according to the director, according to this report. And so I say, well, that's interesting.
Well, Avi, welcome back to the show. It's always an honor and a pleasure to speak to you. How's things been?
Oh, it's quite busy, and thank you for having me. A lot to discuss.
Absolutely. Now, Avi, before we get into some of the work with the Galileo Project, I'd like to talk about the recent hearing that we just had last week, because correct me if I'm wrong, but I believe at some point you were asked if you would be available to testify, and unfortunately you weren't called in the end, but you did prepare a written statement. Could you talk about all of this and how it happened?
Yeah, so in fact, I was contacted already at the beginning of September, very early on. When they just started the process, they even asked me about recommendations for potential witnesses, which I spoke with them about. But then it was about to happen at the end of September, before the Congress adjourned, before the elections. And for some clerical reason, it wasn't possible for them to do it. And then they contacted me again and said that it will be on November 13th, and asked if I'm available. And I said yes again. And I cleared my schedule. I told them that I would be very happy to testify to promote the scientific study of unidentified anomalous phenomena. And basically, as soon as they asked me, I said, you had me at hello. Now, they told me that I have to prepare a written statement, and I did that. For me, writing a statement of this nature is straightforward for two reasons. One, I'm not signed on any non disclosure agreement. I'm writing, the second one is that I'm writing every day or two an essay on medium.com, and anyone interested can go there at Avi Loeb at medium.com. You will see one posted this morning, and it's usually about astrophysics, the universe, also about unidentified anomalous phenomena and the progress we make with the Galileo Project. So I'm very much used to writing. It took me a few hours and I wrote it up. I even, when they postponed the date, I added some details because of the delay. There were some news that I wanted to add. And I told them I have results coming out of the Galileo Project. And then until the last moment, I didn't really know if I'm supposed to go. That was Friday before the week of the congressional hearing. And I got an email from one of the people on X who told me that there are rumors that I was asked. And he asked if that's true, and I did not reply because I wanted to clear it with the people who invited me. And the reply from them on Friday the week before was that here is the list of witnesses, and I was not on it. I'm not sure, there may have been others that were asked, but for me it was really important. I explained it to them. It's important to promote the scientific study of UAPs because we can try and pressure stubborn government agencies to tell us what they know or not know, and that could be a lengthy process for a variety of reasons. I mean, obviously, they don't want to admit there are things in the sky or on the ground that they don't fully understand, because then it means they're not doing their job. And the defense budget is nearly $1 trillion a year. It's a third of the worldwide military expenses of $2.4 trillion. So the US spends a third, and you expect it to know everything that is happening around the territories of the United States. And then it looks as if they don't really identify plenty of objects. And it was obvious when the Chinese balloon was shut down, and President Trump commented that in fact there was a similar incident before. So if they can't see such a giant balloon and figure it out, then you may wonder how many other objects they don't figure out. And that's a humbling thought, because for national security, that's their day job. They need to and of course, everything in the sky, is a mixed bag. Obviously, there are balloons that private citizens put up, and drones that are put up, and then military equipment, and you never know how much espionage there is by adversarial nations. And on top of that, there are civilian aircraft and satellites. There are 6,000 Starlink satellites right now. And I went jogging, as I do every morning, just last week, and it was early before the sun rose. And I looked up because I'm used to looking at the sky. I really love it. It gives you sort of a sense of how small we are in the cosmos. And I looked up, and suddenly I see these green lights and other types of lights that are moving around. And I was shocked because I never noticed it before, because I never looked up at such a dark time. And it was obviously satellites. And in fact, I asked the engineer of the Galileo Project to look at the data during the same time at 5 to 6 a.m. That morning. And indeed, in the data, there were lots of satellites moving around. So there is plenty of stuff that humans make. And then the question is, obviously there are craft that hover around the US or above strategic sites. And moreover, there would be some crash sites, obviously, because every now and then this equipment malfunctions and just crashes. And so, by the way, you would expect every nation, every advanced nation, to have a program for retrieval and reverse engineering of materials from crash sites. That is undisputed. I mean, that's common sense. You wouldn't expect anything else. If you want to figure out what the Russians are doing, and you happen to have some equipment that fell in your territory from the Russians, you would try to reverse engineer it just to figure out exactly how they work. That's a very good clue as to what their technologies are like. And so I completely expect the US government to have a program for retrieval and reverse engineering of materials from crash sites. And if we're talking about aircraft, there could be also biologics of pilots. Okay, so now it's not a question. There is no question of whether such a program exists. It makes no sense for the United States not to have such a program. The only question is, did they find any materials from an extraterrestrial origin that was not manufactured by humans? That's the only question. So when people come out and say the US government has these programs, and the listeners sometimes get shocked. No, that's not shocking at all. That's completely not. You should have expected that. The only question is, what did they find? And for that, we need the data, the materials. And only then, after we see the evidence, we would know. Okay, so if someone tells you, I heard people talking about a program of a very classified nature, and they were saying that it may be extraterrestrial, who knows what these people were saying, because they might have said that in order to confuse the listeners, or to diffuse any attention to what they're doing. It might be all adversarial nations in origin, and they were talking about extraterrestrials so that nobody would suspect that it's actually what the US actually knows. And so until I see the evidence, there is really nothing to talk about. Okay, and that's what I was trying to communicate to Congress. They are going after journalists, people who talk about what they heard. It's always hearsay, and that's not the path forward. The path forward is to go after the sources. So it's not a show, it's not a show on Broadway or in Hollywood where we are trying to impress the audience, which pretty much is what, when you watch these hearings, that's what they look like. The Congress people want to gain popularity among people interested in UAPs, but that's not the real stuff. That's not the meat. The meat of the subject is to get to the evidence. Okay, and to do that, you will not invite a journalist to answer your questions in public. That's not what I would do if I were chair of that committee. What I would do is invite the journalists to have a confidential discussion where the journalists will tell you everything they know, not in front of the public, so that they can really spill the beans. And then I would do some investigation into what they tell me and speak with people at DoD and try to dig deeper into that. Now, that requires much more work. And the lesson I learned on this subject of UAP is that not only UAP, but anything that requires a lot of work, is that most people prefer not to do the work. They are sort of lazy. And so what they do is just express their opinions about it. And that includes the spectators, people that come to the hearing and say, I heard this, I heard that. And the Congress people as well, instead of doing the hard work of digging deeper, they are speaking in front of the public, asking questions, and then move on to the next hearing on something completely. That's not really the way to make progress. Okay, so I would have liked them to do more serious work, and it's not necessarily in the public's domain. They should go behind, and then eventually, bring disclosure to anything of interest. I mean, we are not really asking for information about what we know on adversarial nations. That's not anything to do with national security. Is really not the focus of the people who are curious about the question of what UAPs are. And the only question to which we want answer is if there is anything that is not human. And what is the evidence? Not just, I heard someone talk about it. And since I'm not sure that we will ever get to it, given the elected officials that we have in Congress or elsewhere, or the government administrators that we have at the Department of Defense or elsewhere, instead of asking them and insisting and pressuring them, we can find the answer ourselves. Guess what? We can actually look at the sky. So once again, we can do the actual thing needed to figure out the truth. The government is not the organization for which we should get answers as to what lies outside the solar system. That's not their day job. Their day job is to worry about adversarial nations, national security. My day job happens to be what lies outside the solar system. So because of that, I'm leading the Galileo Project, and all the data that we get will be publicly available for everyone to see. Everything we learn will not require a congressional hearing. And I'm doing it. I just wanted to convey this sentiment to the Congress. And, the chairs of this session did not invite me. What can I say?
No, absolutely. I mean, you mentioned their claims and hearsay. Has anybody ever tried to approach you privately with these similar claims of crash retrieval and reverse engineering of a non-human intelligence?
No, not from government. Uh, the only thing that happened was, I get a lot of reports from individuals that said, I witnessed this and that, and I just don't have access to the actual data that will inform me how reliable the reports are. I was invited to give a public lecture at CERN in Geneva, Switzerland, and there was a special dinner with VIPs, and a few of them, one that was sitting next to me, said, 20 years ago, I saw a giant object, and there was a friend next to me, and it was clearly there. The friend saw it as well. And then it rushed away at a very high speed, and there were fighter jets not being able to catch up with it. So he said that, he's a serious business person, and he just saw that. And so I hear reports of this nature, but you can't rely on eyewitness testimonies in science, because for the same reason that the FIFA does not make a decision about whether a goal was scored in a game based on what the players are saying. FIFA is using cameras to tell us what really happened and whether there was a goal. And so that's what science is doing, that's what the Galileo Project is doing, using cameras to figure out what's in the sky. And just last week, a couple of days before the hearing, as I told the staffers that arranged that hearing, we released the first commissioning data from the Galileo Observatory near Boston at Harvard University. And it included the analysis of 500,000 objects that we monitored in the sky over 5 months. Never before, there was never an observatory that systematically studied the entire sky at a particular location, and then with calibrated instruments that took us a while to calibrate, about half a year. It took us 2 years to put together the hardware, because astronomers built observatories in the past that focus on a small region of the sky, and even sky surveys that just tile the sky, so they look at a small spot and then move around the sky. But what we are doing is looking at the entire sky at all times in the infrared, optical, radio, and audio. And then we have machine learning software that we developed to analyze what we are seeing based on the images of the objects, but also the way they move. And we're trying to figure out, we are training this machine learning on birds, leaves, clouds, aircrafts, satellites, so that they will tell us if there is anything unusual. The one thing that is currently limiting us is that we don't have a distance estimate, because we have one set of sensors looking at the sky from one location. But within a few weeks, we are installing copies of that a few miles away, so that we will have, 2 or 3 additional sensors that will allow us to triangulate. So within a few weeks, we hope to be able to start getting distances, and then it will become very clear whether the object has an unusual speed, an unusual acceleration, and so forth. And so that's coming very soon. And there were data collection endeavors in the past, but they were done either over a short period of time. Obviously, the pilots that we heard about from the previous hearing, for them it was anecdotal. They just happened to be at the right place at the right time. But they didn't do a survey of the sky over extended periods of time. And that's what we are doing over 5 months so far. But within 6 months from now, we are assembling 2 additional observatories at other locations. One of them, very soon, we are putting it together in Pennsylvania. That was an observatory funded by the Richard King Mellon Foundation at $600,000. And then another one after that. And my hope is that by summer 2025, just in about 6 months, we will have 3 functioning observatories that can triangulate. All of them can triangulate and figure out distances. And given that we get roughly 100,000 objects in the sky per month, per observatory. The other thing that happened was a few days ago, there was the 2024 report from AARO with the new director. And the message was quite different, I should say, because they talked about out of those objects that are not drones, about a substantial fraction of them not being identified, and some of them maneuvering in ways that cannot be understood by conventional engineering, according to the director, according to this report. And so I say, well, that's interesting. Of saying we, from a national security perspective, we understand most of these as not being anything to worry about. But from a scientific perspective, even if 1 in a million objects comes from interstellar space, that's the biggest news that science ever delivered. So I'm not talking about 3%, but even 1 in a million, which is something that the Galileo Project can figure out. But the other thing that happened was a few days ago, there was the 2024 report from AARO with the new director. And the message was quite different, I should say, because they talked about out of those objects that are not drones, about a substantial fraction of them not being identified, and some of them maneuvering in ways that cannot be understood by conventional engineering, according to the director, according to this report. And so I say, well, that's interesting, don't you think? Why wasn't that discussed at the congressional hearing? Again, I think the focus should be on facts, evidence, materials. That's the way we will learn something new, not about speaking with people who tell you about their impressions of what they heard from others. It's not up to journalists. It's not up to politicians to find out what lies outside the solar system. This is not what we should ask them to do. They can only tell us about what they hear from other people. The progress will be made by scientists, people who collect scientific quality data and make it available to the public. That's the way to make progress. Now, if you ask how many such people are there, not many, not many. So there is the Galileo Project. No other project is actually building an observatory that collects currently data at the rate that we are. Okay, there are other sort of programs. Some of them just starting, some of them analyze data collected over a few days, things like that. Some of them looking at data from amateurs, which I should say is not necessarily reliable, because nowadays with the software you have with AI, you can easily fabricate videos and images. So I would only trust what one gets with with instruments that you fully understand and you calibrate.
Yeah, absolutely. And I just want to look at the numbers here for your system. You say you had 500,000 trajectories of aerial objects over 5 months. 16% were flagged as outliers, which is an equivalent of 80,000. And it left 144 trajectories that were ambiguous. And I guess with this Dalek unit that's been, that has the sensors, with multiple of those systems, you'd be able to triangulate and work out the speed. But going one step further, would you then gain any insights into the potential propulsion or energy source of that object if it was something going fast?
Yeah. So again, I think data is key, and data in multiple wavelengths. So we currently analyzed infrared data, but we also have optical data in the visible band and acoustic data. And by the way, if you look at the AI systems or machine learning systems, it's an uncharted territory to use multimodal data. So, in other words, just like we humans are using eyes, ears, smell, touch to infer the identity of objects, our brain is capable of using multimodal data. AI systems are not really well developed on that front. And we are planning, we have a whole small team of within the Galileo project of young students that are, and one of my postdocs, Laura Domini, who are focused on trying to analyze multimodal data. So in other words, suppose you have some sound and you see the image. Obviously, the sound arrives at the speed of sound, which is about 1,000,000 times slower than the speed of light. That's why you can see a thunder, you can see a lightning before you hear the thunder. And so the time delay gives you information, even from one location, about the distance, because the sound will arrive later from a different direction. But we are trying to use everything we can measure about these objects in figuring out their nature. And you ask about propulsion. Of course, we would love to have even more data. For me as a scientist, the more data, the better. For people who think they know the answer, uh, they would say it's a waste of time to collect more data, because we know that it's human made, or we know that a meteor is just a rock. We definitely cannot imagine that it's a Tesla Roadster car, even though Elon Musk launched one in 2018 and now on an elliptic orbit around the sun. So I say these people have limited imagination, and the nature is under no contract to make them happy. Okay, so how do we make them unhappy? Those people who cannot imagine anything other than what they already know. How can we make them unhappy? Very easily, by collecting as much data as possible, because eventually they won't be able to dispute it. They won't be able to tell me that an interstellar meteor is a rock if I find a gadget with buttons on it, okay, that came from interstellar space, because the isotopes that I find in the material of this gadget indicate an age very different from the solar system materials. So I can demonstrate in many ways that it's not from the solar system, because anything from the solar system has the same age, you know. Based on isotopes, I can do other tests and make it clear that it's an interstellar object, and at the same time that it's technological in origin. And so what limits me right now is just the lack of data. For example, Oumuamua was really strange, but we didn't have enough data. And then, all my colleagues are saying, oh, yeah, it's a rock of a type that we've never seen before, which is exactly what they would say about Elon Musk's Tesla Roadster car. They would say, oh, it looks red, it's sort of shiny, but it's probably a rock of a type. They would come up with some composition that makes this a rock. And the only way to fight that, people with a lack of imagination, is to get more data, because eventually when you have enough data, they have nothing to say. Then they would say, oh yeah, of course, we thought about it long time ago. We were first. I don't need the credit. I just want to find the truth. And if they come around afterwards and say that they thought about it first, let them have all the credits and honors. It's just that we need to bring closure to this to this anomaly of finding objects that we don't understand near Earth.
Yeah, and I mean, talking about these crash retrievals and reverse engineering programs, people always speculate that it's, whatever these objects represent have obviously cracked gravity. So I want to talk to you about gravity. So how might advancements in, say, quantum mechanics or general relativity sort of lead to the ability to actually manipulate gravity?
Well, okay, so here is a simple example, a simple case. We all know that gravity attracts. Okay, so the way we are familiar with gravity is that we are stuck to the ground on Earth because we are attracted by gravity, and the Earth orbits the sun because it's attracted by gravity to the sun. Okay, now that is another way to phrase it, is to say that the sun has a positive mass. We know that the Earth has a positive mass, but in electromagnetism, we know that there are charges of opposite sign. You have, the electron that has a negative sign, and then you have the proton that has a positive sign. That's why atoms, the hydrogen atom, is neutral, because you have an electron canceling the charge of a proton. Okay, so now let's imagine a world in which there are negative masses in addition to the positive masses. So you just take a positive mass of some value and place next to it a negative mass of the same value. What would happen? The positive mass will attract the negative mass towards it, but the negative mass is producing repulsive gravity, so it pushes the positive mass away. And what would happen is the two of them will move together, one pulling the other and the other pushing the first, and they would keep accelerating together up to the speed of light. No propulsion needed. Now you might ask, how is it possible? What about conservation of momentum? Where does the thrust comes from? In the case of a rocket, you throw some gas through the exhaust, and that's what pushes the rocket. That's how a jet plane flies. Something is thrown back and the plane moves forward. That's the way it flies. But in this case, you're not throwing anything back. So what about momentum conservation? The answer is it's implicit here, because you have a positive mass and a negative mass, and they move at the same speed together. And so the sum of the two momenta is zero, because one is positive, the other one is negative. So now this is an example for a situation where you can get a thrust or propulsion with no fuel, no rocket, just positive and negative mass. So in fact, if you have a negative mass, you can do a lot with it. You can shape it to the form of a wormhole in principle, and go from one region in space to another. I mean, there were studies, some by Kip Thorne and others by other people, that indicated that if we had access to material which produces repulsive gravity, this exotic material can be used to make a wormhole, a stable wormhole. If we don't have such material, we can't build, a wormhole of the type that Albert Einstein and Nathan Rosen envisioned back in the 1930s, that is unstable. It basically snaps away before you can travel through it. So if you have access to this exotic material that allows you to to have propulsion without any rocket, um, then you could also, in principle, build a wormhole and move from one region of space to another through a bridge, and it would look as if you're doing it faster than light, because this bridge may be shorter than the distance between these two regions of space. Another thing you can do is build a time machine, because if you have a negative mass, what happens with a positive mass is that when light goes near it, it's slowed down. The time is slowed down close to a positive mass. But if you're doing the same thing next to a negative mass, instead of getting a time dilation, you get a time advance. Time is advancing faster next to a negative. So then you can, in principle, visit the past and build a time machine, given that. And then, of course, the question is, why? Are we seeing anything from our future? If that's possible. So all of these miracles of either propulsion without any gas coming through an engine, or going through a wormhole, or building a time machine, all of these would be possible if we had access to material that produces repulsive gravity. So you might say, okay, well, that's a fantasy. Not so, because the universe is expanding, but over the past uh, roughly 1/3 of cosmic history, the expansion was accelerating. So, in fact, as if there is repulsive gravity pushing distant galaxies away from us at a speed that keeps increasing. And we understand where it may come from, because in Einstein's equations, if the vacuum has some mass per unit volume, then it will produce repulsive gravity. The vacuum itself, after you remove matter. So it looks like the vacuum dominates the mass budget in the universe right now, but the vacuum is uniform. You cannot use it for any engineering project because it's the same everywhere. If there was a way of excavating the vacuum energy, which, by the way, is called dark energy in cosmology, if there was a way of bottling, putting in a bottle the dark energy, like imagine some factory that extracts energy of the vacuum and puts it in a bottle, then this bottle may have a negative mass, because you managed to put some substance, the dark energy, that produces repulsive gravity in a concentrated region. And so I would not exclude anything until we better understand quantum gravity. We don't have a predictive theory of that combines quantum mechanics and gravity, and all of these issues touch on what might be possible if we had such a theory. And finally, I would say, if there is a very advanced scientific civilization that has quantum gravity engineers in it, what could it do? Well, first of all, you can ask, what happened before the Big Bang? We can't answer this question because we don't have a predictive theory of quantum gravity. We know that as we go back in time, there was the Big Bang. And that's a point in time that we cannot extrapolate beyond, because Einstein's theory of gravity breaks down. And the reason it breaks down is because quantum mechanics should matter at that point in time. But we don't have quantum gravity. If we had that, we would figure out the recipe of what's needed to make the Big Bang happen, right? So it's just like having a recipe for a cake. If you know the ingredients and you know how to put them together, you can bake a cake. So if a civilization understands that, maybe they can start wondering if they can create a baby universe in the laboratory. Even if it's very difficult, at least you would know that it's potentially possible. And the reason I bring this up is because that's the job definition of God. If you ask, suppose we advertise the job of God in traditional religions, what would we put as a necessary requirement? It would be if you want to apply to this job, you should be able to create a universe out of nothing just by playing in your laboratory. And so if a civilization reaches that point where they can apply to the job of God, we would be at awe once we encounter anything they produced. And one reason I'm really interested in searching is because we can learn from a civilization that had many more years of science and technology. Maybe they had millions of years beyond us, maybe billions of years, because the sun just formed in the last one third of cosmic history, and there were most of the stars formed before the sun, and so there was plenty of time for other civilizations to be ahead of us. And it's always, I always enjoy being in the company of smart people because I learn something from them. So if we find another civilization that is more advanced than we are, it's actually to our benefit.
Yeah, I mean, just kind of following on as well, still almost talking about gravity and propulsion. And if there is an advanced civilization or multiple out there, would it make sense that they could potentially harness the power of a black hole for transportation or energy sources to traverse the
Yes,
cosmos?
in fact, I published a paper a month ago exactly along these lines. And the idea was, if you imagine having a black hole that is very small, I call it mini black hole, that has a mass of 100,000 tons. According to work by Stephen Hawking, such a black hole would evaporate, would emit radiation, and disappear within 1.5 years. However, if you feed it roughly 2 kilograms per second, you can keep it at the same mass of 100,000 tons, because that's the rate by which it's losing mass. So you just need to feed it. The way we eat food so that it compensates for the calories we lose during the day. And so 2 kilograms per second is roughly what you get when you flush the toilet. Okay, that's the amount of water that comes down. So if you just imagine flushing the toilet at this black hole uh, all the time, and basically, you can throw trash at it. It doesn't need to be anything valuable. In fact, we can recycle all the trash in that direction. Um, then you will have an engine that gives you 100% conversion of rest mass energy to radiation. Why? Because everything you dump into this black hole will come out in radiation, and you get 100% conversion efficiency with nuclear reactions. You can't get better than about uh, uh, 0.7 of a percent of the rest mass energy. Even if you're burning everything to iron, which is the most stable element, as happens in the centers of stars, that gives you at most 0.7% of the rest mass energy. I'm talking about 100%. The only other thing that gets to 100% is annihilation. If you take matter and antimatter, put them together, you get radiation with 100% efficiency. The problem with that approach is that we don't have antimatter, and CERN produced some positrons, some antiprotons during its history, but it was really tiny amounts. We're talking about micrograms, and the cost was billions of dollars. So it's really very expensive to create antimatter as fuel. And here you just need to throw your trash, whatever you don't like, into the black hole. You get energy in return. And I suggested in the paper that you can put it, a civilization can put it as a moon in a low Earth orbit. And I calculated that a black hole of this mass would give the planet as much energy as the sun does. So even if your planet is not close to a star, it will get as much energy as the sun gives to Earth out of the radiation that comes out of this black hole moon.
Often the UFO subject is filled with a lot of sort of sensationalism and just wild stories, claims, and things like that. How can we use the topic to actually inspire more interest in science, more critical thinking, and especially in the general public who may not have an interest yet?
Yeah, so I think it's really a mistake to to argue that we know the answer in advance, like many believers do, because it's really similar to what happens in politics, where nowadays with social media and the news outlets, you can easily subscribe to a tribe, a group of people that thinks just like you, and all the information you get is similar to what you already thought before, and you feel empowered by that. But you may be on the wrong path, and you'll never know that because you don't open your eyes to the other side. I mean, the last election was all about that, about the fact that a significant fraction of society was not listening to the other part of society. And the elections basically gave a very clear voice to those people who felt that they're not listened to. Okay, and so that happens in politics, where what you find is people are going to the extremes. So either you go to the progressive left, where many of the things being said that do not make sense to most people, or you go to the extreme right, where also the same things happen. But going in the middle, which makes the most sense, is a path that is not populated by many people, because most people are driven to the extremes. And if you were to train an AI system on content on the internet, it would be really difficult to train it on the sort of middle road that makes most sense, because most of the content is at extremes. That's why you see those AI systems, some of them going to one of the extremes or the other, or social media platforms doing the same. The training set of what is most reasonable to do is very limited. Now, what I'm saying is that here, in the context of, I mean, that happens also in religion and any belief system, in politics and so forth. But in science, we have a great resolution to this problem, and that is that we have an arbitrator. The arbitrator is reality, the physical reality. Okay, so think about UAP as an example. The question is, I mean, nobody doubts that there are objects in the sky that we don't fully understand. The director of national intelligence talks about it. The politicians talk about it. Everyone talks about it. The only thing that we don't know is what is the nature of some of these objects. It's probably a mixed bag. There are lots of things that are human made, but is there anything unusual among those? And the same is true from interstellar space. There are probably lots of rocks, but is there any spacecraft among the rocks, or any space trash? That trash will be our treasure if we find it. So how do we make progress? It's not by saying I'm a believer and talking about it on social media forever. That's not progress. That is therapy, maybe psychological therapy, for you to feel better about it. But progress is by finding evidence, by showing the material, or the data that illustrates one way or another. Okay, and that's the beauty of collecting scientific data, that eventually, if you have that data, if the data is good enough, if it's rich enough, nobody would be able to dispute it. The only reason we are arguing about it is because the data is not convincing enough. Okay, if the data was convincing enough, everyone reasonable that looks at the data. Now, of course, there would be people that don't look at the data, just the way that there were people that didn't believe that the sun is at the center of the solar system. There were lots of them, 550 years ago, before Copernicus, when he was born. There are fewer of them now. And we don't really care about those people that are not willing to attend to data. There is a large enough fraction of us that would be amazingly impressed if there was a real gadget that was recovered and beyond any reasonable doubt shows evidence for interstellar materials. That I don't think many would doubt it once the evidence is clear. Okay, so the key is to find it. It's like a treasure hunt. Okay, and my point is that instead of arguing what the Department of Defense is hiding and so forth, which you can spend your life on, and it's sort of like reading tabloids. I mean, you can do whatever you want, but the point is that if you really want to learn something new, the way to do it is by investing time and effort, not in talking about it, but actually collecting the evidence that would demonstrate the answer. Okay, and that's the work of a scientist. And so that's really a great that's great fun. Now, I have a hard time convincing my fellow scientists to do it. Why? Because they say there are all these fabricated stories that do not make any sense, that some people invent. I don't think it's a good argument because the question itself is extremely exciting. So why should we surrender to those people who spread misinformation? That's, that they should not dictate the agenda. The fact that one side of the spectrum, at one extreme is making no sense doesn't mean that we shouldn't take the middle road and collect the data that will tell us what the answer is. So that's my criticism of the scientific community. This should be in the mainstream of science because it's a question that the public cares about, that politicians care about, apparently, and the public and government fund science, and we have a civil obligation to help them figure it out with the tools of science, and we have those tools. It's just a question of funding and putting the resources, the time to do it. And so that's my criticism of the scientific community that is not engaged. But I'm also critical of those believers, that have an opinion that are not engaged in or fully embrace the scientific method, because that's the only way for us to convince the other side if there is something extraterrestrial. And time will tell. At the moment, the Galileo Project is funded by private donations, and we're planning another expedition to the Pacific Ocean to look for bigger pieces in the wreckage of this interstellar meteor. And it will cost $6.5 million. I'm currently in the process of speaking with potential funders. If anyone listening to this is interested in funding, let me know. We have the ship. We have an exceptional research team, and expedition coordinators and engineers that are ready to go to the Pacific Ocean next summer. And if we get the funding, we will do it. And that's the only way to learn something new about either interstellar meteors or UAP. I should also mention that next year there will be a new observatory in Chile, the Rubin Observatory, with a camera of 3.2 gigapixel that will look at the sky. And together with my postdocs, we developed software that will look for UAP in the data pipeline that will become public, as well as look for objects that do not come very close to Earth, like Oumuamua, the interstellar object that was very weird, was flat, and was not exhibiting any cometary tail, even though it was pushed away from the sun. So we hope to find more objects like it. And fundamentally, there are millions of objects the size of a person right now within the orbit of the Earth, around the sun, from interstellar space, based on my estimates. We don't know much about them because they don't reflect enough sunlight. So, and therefore, the current observatories we have cannot detect them unless they collide with Earth as it moves around the sun. And if I had a few $1 billion, I would know exactly what to do in searching through those objects, looking for any technological space trash. It's just a question of funding, and it's pretty clear what needs to be done. And I'm willing to put the time and effort that I still have into this if we get funded at the appropriate level.
Yeah, and one thing I really wanted to touch upon as well is that in the last few years, since we've had prominent scientists such as yourself and Professor Gary Nolan and others sort of come on board into this subject and start looking into it, a lot of people out there seem to have reservations about connections to the intelligence community or the government. And one thing you've always stated is how you're very independent, you will be very transparent. Could you just reiterate that again for people? Because I think that's really important.
Yeah, I have no link, no funding, and no other type of links to the US government. All the funding of the Galileo Project is from private sources. At some point when the AARO, the All Domain Anomaly Resolution Office, was established, the new director, Sean Kirkpatrick, came to visit me. He wanted to know more about the Galileo project, and they learned everything they want because it's open. The information about what we are doing is completely open and transparent. And so I gave him all the information. At some point, he said, "Why don't we write a paper together?" So we wrote this paper that was publicized but never published. And It was just a matter of talking about the importance of scientific research into UAPs. So I was happy to write it with him, but for the same reason that I'm happy to advocate in Congress for more scientific research. But what really matters is whether funding comes in this direction. And in the latest report, there was a mention of an observing system that the AARO is using at some places. And it's very different from the Galileo Project observatory. It's using radio, at least what they describe. I don't know, maybe they copied some of our instruments and are not talking about it publicly. Maybe they did that. I mean, I don't mind that because, Oscar Wilde said that the imitation is the sincerest form of flattery. And, the NASA committee that was established because I approached the head of NASA through the person under him for science. I approached them during the month that Avril Haines, the director of national intelligence, testified for the first time in Congress with the first report. And I said a more scientific study needs to be done. And as a result of that, they never got back to me, and I established the Galileo Project because nobody is doing it. And Then they established a committee a year later, inspired by what I told them. And then this committee, after a year of work, so that's 2 years after I approached them the first time, this committee concluded, and guess what? In their report, which is pretty much what Michael Gold was talking about at the latest hearing, they basically said more scientific research is needed, without crediting the fact that the Galileo Project is already doing that. Okay, but I don't mind. But once again, imitation is the sincerest form of flattery. So after 2 years, they arrived to the conclusion that something like the Galileo Project needs to be established, and I established it 2 years earlier than this report. So the question is not so much what people are talking about or the show that they put out, like in a hearing, or uh, what matters is really what someone else is doing. So it's not about talk. It's about what are you actually doing. And you should ask any person that talks about UAP whether they are engaged in, actual uh, data-driven endeavor, because that's the only way that will bring us forward.
Yeah. So would you be open to working with AARO in the future, or NASA, or any other organization? If so, would you have stipulations?
Sure. I mean, it really depends on if they put any strings attached, you see, and then I will have to weigh. But in principle, I would say that I'm fundamentally I'm curious. Okay, so if they say, if someone says, I don't know who, but if someone says, I have these materials, I have this data, but you will have to sign a document that will imply that you cannot talk about it publicly unless you are authorized to do that. Would you mind helping us? Okay, that's an interesting question. And what I would think is, if it's not a matter of national security, uh, I will, I would like to know the answer. That's really what drives me. I would like to know the answer. Now, the issue, so I would probably try to help them. But the issue is that suppose I do that, and I didn't, by the way, until so far. Suppose I do that, then it will uh, somewhat compromise my ability to speak freely about what the Galileo Project is finding. Because if we happen to find the same thing, there would be a question as to whether we did that because I know something else, you see. Whereas if I'm not signed to any such agreement, whatever we find is public.
If anyone, hypothetically speaking, if anyone was to approach you with anomalous materials, would you be in a position to have the access to the equipment to analyze
Oh,
it?
yeah, definitely, because that's what we did with the materials from the Pacific Ocean. But I should say we need funding for that. It's not cheap to do that. We have the equipment. We published a paper that in a prestigious journal, Chemical Geology, after it was peer reviewed by several referees, all of which recommended it for publication. And the reason I mention that is because there were a number of specific individuals within the scientific community who were bad mouthing this analysis, saying negative things to reporters. And of course, the reporters want controversy, clickbait, so they would amplify the negativity. That's another problem that, because the subject has a lot of visibility and lots of people are curious about it, some members of the scientific community or some science popularizers tend to make negative remarks. And the reason they do that is either because without making these negative comments, they don't have any visibility for their own scientific work. They either never publish anything interesting or didn't even publish over the past decade. I published every month several papers, and I have more than 1,000 scientific papers. I'm actually in the trenches doing the work. Whereas some of these science popularizers, and I'll not mention names, but some of them have very clear opinions about why this is not a scientific research area. But they are not really doing any scientific work, and they pretend to defend science. I would argue that they're doing the work of anti-scientists, because they just argue against the collection of evidence, against the collection of data, by pretending to know the answer in advance. They're trying to play the adults in the room. And what I tell students and my research group all the time is never pretend to be the adult in the room, because very often the adults just pretend to know more than they actually know. And the only way to learn something new is by not listening to the adults and just doing, the scientific work needed to find out something completely different than what they said.
Yes, absolutely. Well, listen, Avi, it's been a fantastic speaking to you as always. What I will do is make sure that links to everything we've discussed, especially your Medium articles, are in the description of this interview. But once again, thank you so much.
Thank you. And I hope within a year we'll have some exciting discoveries that I will be glad to discuss again. So just stay tuned. We are collecting a lot of data with the observatories. Hopefully, we'll go to an expedition, and also from the Rubin Observatory, we might discover some new objects. So the next year should be exciting.
That's fantastic. Really excited for that. Thank you again. And to everyone watching, as always, please go and check out all of Avi's work and support the Galileo Project if you're able to. But for now, we will see you on the next one. Take care and goodbye.